Hello everyone, my name is MD Surabhakhtarima. Today I am going to give the presentations on the artificial potential field algorithm in the learning sessions. So these are the table of contents. First we start with the introductions, then after artificial potential field algorithm. After that we see some shortcomings of this algorithm. Then the solutions of the shortcomings. Then we see the flow diagram of the artificial potential field algorithm. Then we see some application of it, and then lastly the references. So introductions. Artificial potential field algorithm is proposed by the Osama Khatib in 1986. It is one of the most widely applied approach for the autonomous navigation because of the simpleness and effectiveness. So it is very simple and effective for the path planning of the robot that it avoids the obstacles on the way from source to destination, and it continuously move to the goal until it reach to the goal. So and it can achieve the collision and avoidance and the path planning simultaneously. Artificial potential field algorithm is composed by two parts. The first one is gravitational force field, and the other one is the repulsive force field. The gravitational force field attracts the robot so that the robot reaches to the goal, and the repulsive force pushes the robot away so that the robot avoids the obstacles. So generally, the attractive force is exerted by the goal in order to attract the robot if it is in the region attract the robot so that it can reach to the to the goal states, and the obstacle exerts the repulsive force in order to push away the robot so that there is no collision with the robot and the obstacles. The gravitational force is generated by the goal point and the repulsive force generated by the obstacles. The resultant force superposition with the gravitational force and the repulsive force is the acceleration force which define the motion of the robots. So based on the repulsive force and the gravitational force, the both are combined, and both of them will decide the motion of the robots in which order the robot will move. The gravitational force field is decreasing with the distance decreases. So the gravitational force field which is exerted by the goal states will decrease when the distance between the robot and the goal is decreases. So it is logically that if the robot is far away from the goal, the force of attraction will be more so that it continuously move to the goal state, and if it reach the goal state, the force of attraction will be zero so that it will stop to the goal state and not move further. Another is the repulsive force field which is decreasing with the distance increases. uh, so the if the distance between the obstacle and the robot is very minimum, so it needs to avoid the collision. Therefore, the force of repulsion will be more. And if the distance between the robot and the obstacle is very far, so the force of repulsion will be very less. This is logically we can understood. So this is the goal states where the gravitational force is exerted by the goal. So if any robots come in this frame of in this frame of attraction, frame of gravitational force, it will feel it experience the force of it experience the gravitational force and start moving towards the goal states. So the gravitational force exerted by the robot over here will be more, and is as compared to the gravitational force experienced by the robot over here, because the distance here over here is minimum and distance over here is the maximum. The repulsive potential field. This is the obstacle. Suppose so it will exert the repulsive force in order to push the robot if it come in its contact so to avoid the collisions. So the repulsive force over here, if the distance is maximum, so it will be less, and if the robot is over here, if the distance is minimum, the repulsive force will be more. So it will try hard to push the robot away from it, so there is no collision occur. So the resultant force will be look like this. The vector sum of two fields will be, if the force is applied over here and the force is applied over here, the resultant force will be in the combination of those field forces, and it will be deviate from the it will be combined forces of both the repulsive force and gravitational force. So this is the goal states, red and the green will be the obstacles. So the robot is over here will be start feel the experience gravitational force over here is very high, so it will starts moving here in this way, on this way, and it will over here it feels the repulsive force. So the resultant force will be like this. So it deviates from on this path and avoid the collision, and finally follow the path over here with the combination of both the forces and reach to the goal states. There are some shortcomings of this algorithm. There will be a local minima. Attractive and repulsive forces can balance, so the robot makes no progress. So uh, there will be some situations when the forces over the robot will cancel each other, and the resultant force on the robot will be zero. So the robot will comes into the static positions before reaching to the goal states. Closely spaced obstacles or the dead ends or unstable oscillations. The dynamic of the robot environment system can become unstable in some situations. It may get jump out of the goal states by experiencing some closed obstacle, repulsive forces, maybe the high speed narrow corridors or the sudden changes. So this is a local minimum problem. Suppose the goal is over here and the robot is here, so it will feel the repulsive force from the obstacles and these obstacles, and the goal states uh, exerts the gravitational force in this direction and in this direction. So these four forces on the robot will cancel each other, and the resultant force on the robot will be zero. So it will come here in the static position, and there will be no movement from this position. So this is the problem of local minimum in the artificial potential field algorithm. Box cannon problem. Suppose that the robot somehow reached to this box. So these are the obstacles which exert the repulsive forces on the robot, and the robot tries to achieve over to the goal. So from here, the robot will. There is no chance that it can reach to the goal, or it may also not escape from this box. This is the dead end where if the robot go inside it, it will not. There will be no chance to reach to the goal. So for avoiding these types of box cannon problems, we avoid the past potential field. So we avoid the robot to fall in such situations. uh, by changing for fall in such situations. Now the rotational and the random fields. The solution of the previous problems is the rotational and the random fields. So the earlier we applied the straight fields. So the in some situation the resultant force will be zero. If we applied the rotational field, the if the goal the robot will not stuck at any position and it will move. If there is a local minimum problem, it will move to the other position, and after that after there robot will try to reach to the goal states. Adding a rotational field around the obstacles breaks symmetry, so it breaks symmetry, avoids some local minimum, guides the robot around the groups of obstacle. A random field gets the robot unstuck, avoid some local minimum. So similarly, over here the random fields will also move the robot to another direction. So there from there the robot tries to reach to the goal states. This is the flow diagram. So WMR is the wheeled mobile robot. So first we said the start set the goal location, initialize the heading angle in which direction the robot tries to move, receives the coordinates location of WMR, calculate the direction of the goal, and then calculate the repulsive forces from the environment if there is any obstacles. Thereafter is the goal block. There will be two answer of this, yes or no. If the goal is blocked, find the new temporary local goal and calculate the new attractive forces so that it can move to the some other new goal from where it will try reach to the actual goal states. If the goal is blocked, or may the local minimum problem arises. If no, then combine the total potential field force, control the WMR motion, and calculate the heading angle. Is the goal reached? If yes, then stop. If no, then it is, will start from receive the coordinate location of the W. We build mobile robot, and this process is continue until the goal state is reached. There are the applications of the application of the artificial potential field algorithms. The mobile robotics application field algorithm is widely used in mobile robotics for navigation and the obstacle avoidance. Robot use APF to navigate to in complex environment and avoid obstacles. Autonomous vehicles in recent days, the autonomous vehicles will use this use APF algorithm for the motion planning and the obstacle avoidance simultaneously. The algorithm helps the vehicle navigate safely and efficiently through the environment. So it avoids the pedestrians and the other cars also, and it continuously moves to the goal state until it reached to the goal. Robotic arm control. So the algorithm can help also be used to control the motion of the robotic arms, enabling them to perform complex tasks such as pick and place operations and avoid the obstacles as well if there is any on the way. So these are the references I have understood about the algorithm and take the help of this IEEE paper and these Texas universities. Thank you.